Welcome to A-Star Science, part of our GCSE Must Know Chemistry series. Today we're going to be talking about the Haber process. And I have an image on the screen of bags of fertilizer. You know it's fertilizer because it has the initials NPK on it, which N stands for nitrogen, P stands for phosphorus, and K stands for potassium. And this is another unit that you actually have to learn about for your GCSE. But these particular chemical elements make up many of the world's fertilizers. They're very, very important for the health and growth of agricultural products. There are thousands and thousands and thousands of tons of these fertilizers made from industrial products. And one of the key fertilizers in this particular formulation is nitrogen. Nitrogen is one of the key ingredients in this fertilizer. And one of the key chemical reactions that takes place to form this nitrogen is called the Haber process. And that's why it's so important for you to learn about the Haber process. It is really important for the world's industries and is a big factor in the industrial production of some of the pollutants, including, greenhouse gases, because it is an industrial process, as well as, unfortunately, runoff, causing things like eutrophication, which is a unit that you have to learn about for GCSE biology. So what is the Haber process? Well, it's when you take nitrogen plus hydrogen. Nitrogen is abundant in the atmosphere, so it can harvest nitrogen, as well as you can get hydrogen as well. So if you take nitrogen and hydrogen, you can make ammonia. And ammonia is a source of nitrogen that you can use for fertilizers. Now, this reaction is reversible. So we're going to use a reversible sign, and we need to balance it out. So we're going to put a 2 here, and that means we need to put a 3 in front of the hydrogen. And so now that's balanced. So this is the Haber process. It's a reversible reaction because we can see the reversible reaction sign. Now, because this is so important in industry, this particular reaction, scientists want to and manufacturers want to use the best conditions possible so that this reaction happens at the fastest rate possible and at the highest yield possible. So how do we do that? How do they do that? Well, we need to remember Le Chatelier's principle because this is a reversible reaction. And so the Le Chatelier's principle applies to this. So let's first look at the temperature. So we know that if you increase temperatures, that normally results in a faster rate of reaction. But this reaction is an exothermic reaction. It's an exothermic reaction. So in this case, if we increase the temperature, that actually is going to reduce the yield of ammonia. So what scientists need to do, they do not want the temperature too low because that will slow down the rate of reaction. So they use a compromise temperature. That means it is high enough so that there is a decent rate of reaction, but it's not too high so that it drives it towards the endothermic side. And that temperature is around 400 degrees Celsius. That's a compromised temperature. Remind yourself that if the forward reaction is exothermic, if I do heat this reaction up, it's going to drive it the opposite way towards the endothermic side. And that's not what we want. We want to drive it towards the right-hand side because that's going to increase the yield of ammonia, which is our desired product. We can also affect the rate of reaction with pressure. we know that the higher the pressure, the higher the rate of reaction. But Le Chatelier's principle applies, which says that in a reversible reaction, the higher the pressure will move it towards the side of the least moles. So in this case, we can see that on the right-hand side, there are 2 moles of gas, ammonia gas. Let's put our state symbols in. But on the left-hand side, there are 4 moles of gas. There's 1 mole of nitrogen and 3 moles of hydrogen. That means with a high pressure, Le Chatelier's was said will move it towards the side of the least moles, which is the right-hand side. So this is something we want for our conditions, the high pressure. And in this case, you do not need to know this for the exam, but we're going to tell you anyway. The reaction is carried out at about 200 atmospheres, which is 200 times of normal pressure at sea level. Now, how else can we increase the rate of reaction? We know that we can use a catalyst because catalysts speed up the rate of reaction. So in this case, for the Haber process, an iron catalyst is used. Remember, we use transition metals like iron, platinum, and nickel for catalysts. In this case, an iron catalyst is used. Now, it's really important for your exam to say that although we use a catalyst, it's going to speed up the reaction, but it doesn't increase the yield. It does not increase the equilibrium yield. This is very important to make sure that you say in the exam. It speeds up the reaction. That means you will reduce the energy you use, which of course will reduce the costs. So let's summarize very quickly. In terms of the Haber process, you do not want a too high temperature because that will shift the reaction to the endothermic side. So we use a compromised temperature. It's hot enough to have a decent rate of reaction, but not too hot that it will shift it to the left, which is the endothermic side. We use a high pressure because this is going to move it towards the side of the least moles, which is the right-hand side, which only has 2 moles, compared to the left side, which has 4 moles. And we also maximize the reaction by using a catalyst. In this case, we're going to use an iron catalyst to make sure we can maximize the yield as much as possible. This speeds up the reaction, but does not affect the equilibrium yield. In other words, you're going to make the same amount. You're just going to make it in a quicker time. So this is the Haber process. Really important reaction that you need to understand that links to Le Chatelier's principle. If you're not sure about Le Chatelier's principle, please go and watch my video on Le Chatelier's principle. Make sure you like and subscribe to the channel and leave a comment below. Let me know if there's any particular video topic that you'd like me to do.